Hello everyone, welcome to this video where we are given a regular hexagon. Regular means all the sides are the same, are equal. So it will be 2 cm each for A, B, B, C, C, D, D, E, E, F and F, A. And this is actually the base of a right pyramid. And the pyramid height is given 5 cm. Well, for part A, let's zoom in on part A. We are supposed to find the area of this hexagon. And we are also required to let x be the unknown side, which is this, of a triangle. And that will actually help us a lot, because I am going to share with you that and ask you to focus on this particular triangle here, where I have x. This is 1. And this is 2, because the whole triangle is an equilateral triangle, right? So all the sides are 2, 2, 2, 2, 2. And why is Mr. Tan though then very interested in finding or knowing this as 2? Because I'm going to ask you to zoom in on this right angle triangle. Can we find x using our previous knowledge of Pythagoras theorem? Yes. So x square plus 1 square is equals to 2 square by Pythagoras theorem. So I will have my x square is equals to 2 square minus this one. Applying the algebraic manipulation, I will have minus 1 square on both sides. So my x square will be equals to 3. So my x is the square root of 3. And knowing this, allow us then to find the area of the hexagon. Because looking at the triangle now, where this part here is now 2, and this the height, which is given by x, is square root 3. I can then find the area easily now, because the area will then be equals to, so the area of the hexagon will be equals to, first I have this triangle, half times base times height. This is for one triangle. How many triangles are there? Yes, I have 6 of them. And that will give me a value of 10.3923 to 6 significant figures, followed by 10.4 cm square 3SF. Alright, so that's for part A. For part B, to find volume, given in this question, right, they actually give us a very important information, which is the pyramid. The height is 5 cm. And so, with this square base, the volume then is pretty straightforward already, because volume of a pyramid is 1/3 times the base area times the height. And I do know my base area. We just find it here. This hexagon is actually the base. And notice what Mr. Tan do. To get a very accurate answer, I don't use my 3 significant answer. Instead, I use my 6 significant figures answer. The height is 5 cm as given in the question. And then this will then give me my final answer as let me just write it down here. 17.3205. Again, I like to leave my answer to 6 significant first, followed by 3 significant figure. 17.3. So part A is done, part B is done. Let's take a look at the pyramid then. How then are we to find the slanted edge of this pyramid with the hexagonal base being drawn here? Alright, so for this particular question, we are literally looking at this particular length here. So I am going to make use of this part here, right? This particular triangle, and this is actually the height of the pyramid, 5 cm, that is given already. The next question is, what is this blue color length here? So I'm going to go back to this original dimension here. Do you see that if the height is at the center here, we are literally having this point C here, and this is point N here, and these are all equilateral triangle, meaning if this is 2, this is also 2. And so again, we are looking at another right angle triangle, and I am going to call this slanted edge as Y. So Y square is equals to 5 square plus 2 square. Making use of our knowledge of Pythagoras theorem, and this will give me 29. So Y is equals to the square root of 29, and then again giving my answers first to 5 significant figures or 6 significant figures around there. 5.38, 516, followed by 3 significant figure, 5.39. And the last particular question, find the total surface area of this pyramid, which we have drawn out the net. So we are essentially finding the 6 triangle. 1, 2, 3, 4, 5, 6 equal triangle, and the hexagonal base, which we already have from part A. So the main challenge here is to find this particular green color triangle, where I would then have to consider, I'm going to draw out this, okay? So here will be 2, and I know this, and the edge. Notice what Mr. Tan used. Mr. Tan actually used this most accurate answer, square root 29. So I'm going to just draw this green color triangle out. Just do a rough sketch. And if I were to break the 2 into 2, I will actually have here as 1 and here as square root 29. Will I then be able to find this height of this triangle? Yes! Again, we are going to make use of our right angle triangle, the Pythagoras theorem again. H square plus 1 square equals to square root 29 square. So using this, I will then be able to, by applying or doing some manipulation, algebraic manipulation, I will have to minus 1 square. And this will actually give me 28. So my h is the square root of 28. And then I will be able to find the total surface area already. Because the total surface area will then be equals to half times base to height. We just found out to be square root 28. This is one triangle. How many are there? 6. Plus the answer previously from part A, which I'm going to remind everyone again, 10.3923. 10.3923. This is answer from part A. And this will give me the final answer of 42.1413 to 6F. SF, significant figures, followed by 3 significant figures. And with that, we have come to the end of this video. That require us to find volume, surface area, slanted edge, total surface area of a hexagonal right pyramid. Well, if you like this video, do give it a thumbs up. Thank you for watching and have a nice day.